Question 12. A box of mass m kilograms is at rest on a rough slope inclined at an angle theta degrees to the horizontal. It is then held in place by an external force of magnitude F newtons, which is at the same angle theta degrees to the slope as shown in the diagram. The box is on the point of sliding down the slope when F is equal to 1/2 mg. Show that mu, the coefficient of friction, is equal to 2 tan theta degrees minus 1 all over 2 minus tan theta.
So, this is a question on forces. So if it's a question on forces, which one of Newton's laws do we use? Well, we use the first law, because we have a body on a slope that's at rest. And if the body is at rest, then the forces on it are balanced, which means in any direction we choose, we add up the forces along that direction, we'll always get the answer 0. So how do we approach this? Well, it's systematic approach. The first thing we do with all of these questions is draw a free body diagram. So we draw a diagram with all the forces acting on the body. And when we've done that, we then decide how we should resolve these forces. Well, the block's on our slope. So we usually resolve our forces along the direction of the acceleration or the intended acceleration, or what the acceleration would be if the forces were unbalanced, and that would be down the slope. So we resolve our forces in a direction parallel to the slope and a direction right angles to the slope. When we've done that, we then make two statements, one for the direction parallel to the slope and one for the direction at right angles to the slope. When we've got these two statements, we have done the physics. And after that, or we have done the mechanics, if you like, and after that, it's a problem in mathematics to get to where we want to go. Let's draw a free body diagram there. There's the applied force F, which is equal to mg, angle shown, as required by the problem. Mg, that's the force the Earth exerts on the block, that's the weight, and that always acts vertically downwards. There's the normal force, and the normal force is the force the slope exerts on the block, and that's always at right angles to the slope. And finally, we put in mu times n, that's the force of friction acting up the slope. It's acting up the slope because the block is about to move down the slope, and the force of friction is always opposite to the direction of the motion of the block or its intended motion. And that's a very, very important point to bear in mind for the next part of the question. After that, we put in our coordinate axis and we refer our vectors to that diagram for the purposes of clarity. After that, we start resolving. So these are our four forces and the coordinate system that we have chosen. First of all, I'm going to declutter my diagram and shift the force of friction mu times n along the slope, but still aligned with it. Then I'm going to complete the geometry, and you can verify yourself that mg makes an angle theta with a negative y-axis. Now I resolve mg into its two components, right angles to each other. One component down the slope, mg sine theta, and a component perpendicular to the slope, mg cos theta. But notice both of those are in the negative direction according to our coordinate system. They're in the negative direction, so we have to assign a minus sign to these two components. When we resolve our external force with half mg, then we get half mg cos theta and a half mg sin theta. Both of those are positive. And if you notice that the normal force and the force of friction, they're already aligned with the slope, so we don't have to resolve those. And again, those are both positive. Then we make our two statements. We collect the x terms and make them equal to 0, and we collect all the y terms and they also add up to 0. And when we've done that, we have done the mechanics of the problem, or the physics of the problem. Solve the equation simultaneously and then find mu in terms of our parameters. And if we do it all properly, we should get the right answer. Part B. When theta is equal to 30 degrees, the external force is increased so that the box is on the point of moving up the slope. B. Determine the magnitude of the new force and express your answer in the form kmg, where k is a constant. So the first thing we do, we should find the coefficient of friction. This is our expression. 2 is an absolute value, and we don't know what the limitations on 30 degrees is. So what I've done, I've put all the values into the calculator and take it to 3 decimal places in the end. I get 0.109, and that's the coefficient of friction at 30 degrees for our problem. And this shows you how the diagram from part B differs from part A. K is greater than a half, so kmg must be greater than 1/2 mg, and that's reflected in the diagram. And the other change is this, well, the box is about to move up the slope, so the force of friction has to be down the slope. Remember, the force of friction is always opposite to the direction of the motion or intended motion, and that's the only change. This screen shows how our x direction changes from part A. Half is replaced by k, and mu n is replaced by negative 0.109. For y direction, the only change is the half is replaced by k. Write these two expressions down. We solve for kmg. In this case, we don't need to cancel out the mg's.